Good morning students, my name is George and today we will be discussing about molarity. The concept of molarity is very important in chemistry. So let us see first what is molarity. Molarity is usually denoted with capital M and the definition of molarity is nothing but number of moles of solute that are dissolved in 1 liter of solution. 1 liter of a solution. So that gives us the definition for molarity. Molarity is nothing but number of moles of solute that have been dissolved in 1 liter of a solution. Or you can simply say the ratio of number of moles that are present in the solute to that of 1 liter of the solution. Now, when you want to calculate the molarity, the first basic step that we should be focusing is on number of moles. So, how do we calculate number of moles? So, let us see how do we calculate the number of moles. Number of moles is usually denoted with small n. Number of moles is usually denoted with the small n. And the formula for this is given weight by molar mass. Given weight by molar mass. So let us have one small problem on this. For example, if there is a question that has been asked to find the number of moles that are present in 40 grams of caustic soda. So now the question I am going to write down here. They are asking you to find number of moles. Find number of moles that are present in 40 grams of caustic soda. Yeah, caustic soda, we need to find the number of moles that are present in 40 grams of caustic soda. So you should know what is caustic soda. So usually we call sodium hydroxide as caustic soda. So here I am writing sodium hydroxide. Another name of sodium hydroxide is nothing but caustic soda. So the formula for this is NaOH. NaOH. So after calculating the molecular mass of the sodium hydroxide, then we can get the number of moles that are present in 40 grams of caustic soda. So let us see sodium hydroxide. So we need to calculate the molecular mass of all the compounds that are present here. So usually here we have sodium atom, oxygen atom and hydrogen atom. So we need to calculate the atomic mass of this each. So atomic mass of sodium is how much? So we will make it as 23. Then for oxygen, atomic mass is nothing but we will take it as 16, and for hydrogen we would make it as 1. So here totally how much do we get? We get total here 40. So how much do we get? We get here total 40. So what did we do? We calculated the atomic masses of each individual. Okay. So here sodium hydroxide we have calculated and you can see 23 for sodium, and oxygen is 16, and meanwhile this one hydrogen is 1, 0, 1, it is, don't get confused as 1 or 1. I calculated it and made it as 40. Now we have got the molecular mass of sodium hydroxide, which is nothing but 40, and the given mass that is in the question is already given, it is already 40. So 40 by 40 we get it as 1 mole. So the answer for this is 1 mole. So how many moles are present in 40 grams of caustic soda? You can say the answer is as 1 mole. Now similarly, if you go for another question, the question I am going to change. For example, now you need to find number of moles that are present in, instead of taking 40 grams, I am going to take it as like somewhere, let us say, 250 grams of calcium carbonate. 250 grams of calcium carbonate. So So here also we need to find number of moles. Why we are finding number of moles? As you remember, initially we have discussed that molarity is nothing but number of moles of solute that have been dissolved in 1 liter of solution. So that's why we are primarily focusing on number of moles. After understanding clearly how to get number of moles, then we shall move on how to calculate the molarity. Now we need to calculate the number of moles that are present in 250 grams of calcium carbonate. Again, we will calculate the calcium carbonate individually the atomic masses, then sum this up, then get the number of moles. So calcium carbonate formula is CaCO3. So calcium is the atomic mass of calcium is 40, and carbon here I would say it's 12, and oxygen is how much? 8 plus 8 is 16, and here we have 3 atoms. So I would say 16 into 3, that is 48. Okay, so totally summing up this, we would get 100. So 100 is the one atomic mass of calcium carbonate is calcium carbonate molecular mass is 100 grams. So number of moles, so I will finally conclude this. Number of moles of calcium carbonate, given mass is 250, and calculated molecular mass of calcium carbonate is 100. So what do we get, children? We get 2.5 moles. We get 2.5 moles. So that is it. So later in the next class we shall discuss how the molarity is obtained by using this formula. Thank you.